In the present class, we learn about use of two important commands, shaft and groove. They are analogous with PD and pocket. Similarly, two commands, shaft and groove, are very, very important in Catia solid modeling. So the lesson what we are going to deal here, use of shaft command, creating shafts, circular shapes, creating circular grooves, combination of pad and groove pocket commands, and also creating some machine parts we will create hex head bolt profile that we have to use the shaft and shaft or groove commands, and creating pipes and bends and use a command list, and some more things also we will learn in addition to these things in this class. So I will open Catia supply without any product. Now I have to open part design. Open part design. You assign a part number or give a part number. Let us say this is a KFT shaft. As you know, shaft is a circular bar. How we can create that? We have learned in pad by making circular and extruding it. We can create drawing that is draw a circle and extrude. We get the shaft, but it also be created in a different way. Then I will give the name shaft is here. As usual, I will select the work plane, define the work plane, and then I will save this drawing. Like this, I will save this drawing in some place. Once again, I will save it. It is somewhere here. I have to save in here. I will save. I will say shaft. Okay. Now in the shaft command, what we have to do is first we have to select the line, center line of the shaft. You see where it is. So for that we have to go to the sketcher plane. YZ. We can take YZ as a plane and we come out of the design plane, 3D plane, and go to sketcher plane and select a shaft axis. This is called an axis. This is a separate line. It is not a line, but it is an axis. So you have to click on this and draw it either this way or this way, depending upon that how you need the shaft alignment. So you draw it horizontal line. You can draw like this also. It will be inclined. And now we draw horizontal like this. It may be of any length, but it should be there. A minimum length may be anything, but the line should be there in order to make a use of shaft command. Once you draw it, you select the line, click here, center point you select, and assign a value to this. Say this is about 53. 50 I will make it. This 50 it becomes the radius of the shaft. I will let you know how it will be. And now from this point you draw. This is the length of the shaft, and you have to assign length. Say suppose it is 200. Length is 200. Then you have to click here. Line once again you have to draw a line and join them. It is a rectangular line and join them here. Okay, this is a rectangle. No, the axis is already there. Axis should be there, you cannot erase it. Now you come out of the sketcher plane, do like this, clicking, and then this is the command shaft. So you have to click on this. When this is selected already, suppose not selected, you have to select it. You have to select it and click on this. It has 360 degree. The shaft will be complete 360 degree, one revolution, and it revolves. If the command used in AutoCAD is revolve, same way it is used. And you click profile thickness and all, you don't click now, you just click it. This is the shaft. So this can of course can be drawn by using a pad command. Here we are using the shaft command. This is how shaft can be drawn. Now I will draw some flanges, etc. Or let us say we will modify this bracket, bell housing, bracket, etc. This shape can be anything. Suppose you want to modify, you just delete these things and you draw like this. The command shaft is already there. Either you can draw it from scratch, and same thing you can modify. A different section I will show, I'm sure. Like this. Now if you want to give an angle to this, click here, click here, click here. Say this angle is 19 degree, I will round it up to 15 degree. This angle. And this we want to make it vertical. This we have not assigned. And then you can trim it. Please note, it should be a closed figure to draw the shaft. Okay, and we can also dimension. We have to see constraint or not. So it can take up the dimension. We can give them, say this. We can change it to 70, some value. So this has to be constraint horizontal. So what I do is I remove it. I will make it horizontal. And click. This view. See here we constraint, we are not geometric constraint, we are not maintained. That's why we are getting like this. If we have now, we will get all right. We have to select geometrical constraint. We have selected now. I'm erasing and redrawing the whole thing so that the constraint will be automatically applied. Put here. First I have to draw a center line, axis, that is called not center line, it is called as an axis. It may be of any length. and drawing a frustum, you should say. It is not a shaft, now it is a frustum. Shaft is parallel. Now this is a frustum. Let's say this is 20 mm length. And from here we draw another length. It may be anything, it may be longer also. Not necessarily it should be this up to here, it may be any length. And angle we can assign. See, I will call it as, see now it is constrained because I have selected this. The geometrical constraint is as constraint. Now we draw it vertical. Then we draw from here. And see, in all these cases, the figure should be closed. Axis is already we have drawn. Now, if you want to see whether it is over constraint, you just click it. So this is the thing. So this I can change it to 70 degree. So I can't constrain this because it becomes over constraint, because this and this angle is constrained. So once you change any one of them, its length will be automatically adjusted. Now you have to update it, and you got that one. Okay, this is how we can use the command. And similarly, I will draw one more. I will delete this. We can draw the sharp command used to curved profiles also. So I will remove this. Remove the line also. Update, nothing will be there. Delete this also. Now we will draw the command once again. Sharp command we will use once again. Now click on this visor plane, or we will take now a different plane, XY plane. XY plane. Now it is vertically upward. So perpendicular to paper, the axis we can't draw. Now this plane we can draw it in X or Y directions. It is X or Y direction. Suppose we draw it in the Y direction. So suppose we have drawn a line and you want to convert it into axis. You just select this, and click on this. It will ask you, select the line will be transformed into an axis. Do you want to transform? Yes. Make it is being transformed. Now I will show you how we can have the profile curve. So suppose I want to have this a curved profile. So let us say this is an arc. Okay, like this. Center. No, face we are going to make it curved. So what I do is draw like this, some curve profile. What we can do is we can draw a circle here, and then just draw like this. I want to show you a profile to be curved. Draw a circle, a slight profile will create like this. Okay, now draw a line from here, and you want to cut it. You want to have circle, some value you want to give, you can give, say 40 or say 20, 30. Okay, now you can trim this, and this has to be, oh, this is wrongly trimmed. We'll correct it. Only this portion should remain. So we have to retain this portion. Click on this, and then you also this portion to be removed. So with the axis you can trim. This is the profile. Now you have to remove this line. Okay. Now you draw. Just to show you how complicated profile can be drawn. Now you close this, and now just see, you come out of the sketcher plane, oh, somewhere hidden, come out of the sketcher plane. Now you apply the sharp command. Select. See. Here you can see the profile here. See, this is having a curved profile because the line is curved. It is a curved profile. Okay. I will bring the tool as somewhere missing option. I will select toolbar. We are not seeing the tool no? Here. The sketcher plane tool, that I am bringing it back. Customize. I have locked it, I will just remove the lock or unlock it, and then I can bring it down. Somewhere on. I will put it here. Okay, and let me see where it is. See. Now I will lock it. It's better always to lock it because it will be slipped somewhere and it becomes difficult to remove. So now perhaps we can see this. Yeah, we can see it here. Even if that is not visible, suppose see sketcher plane tool is not visible. Suppose this is not visible, then if you click on the plane, it automatically comes back to 3D plane. Okay, this is how we have drawn curved surface. I will show you the surface once again. This is the surface. Okay, suppose you want to give some value, different value for the radius. Click it here. Radius is already given somewhere. So we'll see where we have given the radius here. This, if you want to change, you can change it to 40. It automatically adjusts it. See, since the figure is constrained, it is adjusted automatically. So curve, this is the surface curve. So this is how we can draw the curved surface. Another surface, even this surface, the diameter also can be made curved. So I will just show you this. Click here, remove that line, add here. See, diameter also can be made curved. So this is how we can use the shaft command. So we can create in solid. Now we will see how we can do a hollow section in the same shaft command. We'll see how we can do the hollow section. Now what I do is I will come back, update it. So gone, delete. Now, once again, we'll select YZ plane, that's the more convenient, and make an axis, and make it horizontal. You want to make it vertical also. So then what we have to do is from here, click here, like this. I'm maintaining some thickness here now. Suppose you want to have some thickness, say, let us say. Okay, then it should be a closed figure, it should not be open figure. So what you have to do is you have to trim it off. Like this. And like this. Now we can give values from here to here. We'll say 6 we have here. So let us see 50. Now this the other length. See, you want to make it 10 mm thick, then you make it this 40. Okay, and this length you can always select any convenient length, say 200 or less. Now Now you can apply shaft command. See, this is hot. Okay. See how we can create hollow section also. Now, in this itself, we can make a taper section. So here you want to have a taper. Let us see how we can draw it. Click here. Click here. Make it parallel. See, it shows once it is shown highlighted brown color, it shows it is parallel. Parallel. And then you can trim from this, and you have to remove this line. Remove this line. Remove this line. And remove this line also. You want making a taper. Click here. This is taper. So angle you can assign. Say 4 degrees. So let us round it up to 5 degrees. It's 5 degrees. Because this remains parallel. So here parallel sign is shown, it always remains parallel. And length you can assign some length to this. Say 10. This is also maintained. And another value is from this point to this point, we have to maintain certain length suppose the figure to be constrained. So from here, click this, click 40. So now the figure is totally constrained, and the length, this length, let us see. This length is not constrained. Click here. See, this length is also constrained. So this length will make it 250 if you need. So now you come out of the screen. Because we have already created shaft command, it shows like this. So you update. See, it's a tapering. It is a tube, first of tube having certain thickness. Okay. So this is how we can do it. This is 10 mm thickness. And one more thing I want to mention is the diameter will be twice of this on this side and twice of this on the other side. This is the radius, the central line. This is the central line of the shaft or the axis of the shaft, and this is the radius, and double of the size is, say, it is like this. Okay. See, shaft is completely rotated. We'll do one more thing now, exercise. I will delete the whole thing. Okay. You come out, update it, delete. Now suppose we want to draw a sector, not the complete shaft, then a sector. What we have to do is, as usual, said, come to Catia L, select the sector line, axis, draw an axis of any convenient length. Then you select this as usual and give a value, say 30. Say this, you give a value of say 150. And then you join as usual what we did last time. Only modification changes will be in the 3D plane. So shaft you select. So here we have selected the first angle is 360, second angle is 0. Suppose you modify it to 350. Let us say this I add it as 350. Let us see what is going to happen. So it should be, this angle should be, suppose I make this 360 and this angle should be 350, let us see. The sum of the two angles should be less than 350. So what we have to do is, we will see 10, and this is 50. So the difference, we'll see how it appears. See the difference. This first angle, this piece is not shown, only it is not after that. Here we can say 90. See how we have drawn this. See, 90 degree, first angle is 90 degree. From here it starts. See, here he has given you details, and it ends at 200 degree. 90, 200, the difference is 110 degree. So this is how it is done. I will just show you the plan view. See, we start from 90 and then gone up to 220. So this the remaining portion is the difference, 360 minus 290, that is the angle. I'll show you this. See, the total angle is 200 plus 90. That is 290. This angle is, as you can see, 290. So total angle is always 360. So it means it is 70 degree. This is 70 degree. From here to here, 70 degree. Suppose we want to reduce it. Say this is, you want to make it, say 70, make it 70. See, now 70 plus 270, you start from 70, moves up to 70 degree in one direction, and it has to increase, so it is in the other direction. Suppose I make it minus 70, then let us see what is going to happen. See, this is minus 70. See, we have second angle is 200. From this point it has started 200, and then from that we have deducted this minus 70. So the remaining angle is this is, that is 270 is deducted, and 200 out of 360 you deduct 200 degrees. Then that is the remaining is the angle, this angle. Okay. See, the only thing is some of these two angles should always be less than 360. Suppose we say first angle is 0, and second angle is 200. Let us see. So first angle, so 0, from 0 it starts and covers 200. Suppose it is only 10, let us say 10. See, this is 10. This is how it covers. And suppose this is 20, say 30, this is that. So in the view, it's like this. It becomes sector motion. So anything from 0 to 50 you can make it. We can go up to 360. Okay, this is how we can do. Now this is how we can do. Similarly, if you have a taper, that is also issue, taper or thickness. Suppose you have a small thickness, how it appears, let us see. So what we have to do is, we have to trim it off. Now, in this line we have to remove. So it should be always be axis in a closed figure. Now we just see how it will be. So this is a arc piece. See, this angle we can always change. You want more It is 50 degree. If you want 120, then you can 150. You can make even 300. Fine. So we can draw like this. Okay. This is how we can draw the shaft. Next, we will go to groove this thing. So I will do it in the next session. I will close it now.